Okay, so we are talking about how a string will be accepted by a DFA. So, then we will move to the regular languages. So, the regular language is basically the set of all string which is accepting by that DFA is called by a DFA is called regular language. So, just to recap, so we have a DFA. So, DFA is 5 tuple. So, this is the set of all possible state, this is the set of all possible, say finite set of, these are all finite, this finite, so number of state is also finite. This is the set of input symbol, this is the delta, delta is the function, this is the rule. I mean we are at current state, say q, and we take input, say a will go to p. So, delta of a q comma this. So, we take, so this is a function from q cross this is the state, and take a input alphabet, it will go to the new state, and then this q 0 is a starting state. So, q 0 is, this is the initial state or called starting state, starting state. And then f is a subset of q which is called final state or the accepted state. Okay. So, now this delta is defined on a single input. Now, we have seen how we can read a string, I mean the collection of input, sequence of input by a DFA. So, this is like this, suppose you have a n. So, we will start from the starting state. We will first read this, suppose it is reaching to q 1, and then again we are at q 1, we again read a 2, suppose it is q 2 like this. So, finally, delta of q n minus 1, and we read this. So, this is the, so we have this a 1, a 2, a n, we are keep on reading this, and every time we are changing our state, and finally, if we are reaching to a q n, and if q n is, this is the way we read a string, instead of if q n is belongs to f final state, then we say this string is accepted by our DFA A, otherwise this string is rejected. Okay. So, this is the way we define. So, we take an example. We take an example, consider the DFA like this. So, we have state A, B, C, B and C. So, A is the starting state, say A is our q 0. So, from A, if we see a 0, we will go to B, and if we see a 1, we will remain at A, and from B, so if we see a 1, we will come here, and if we see a 0, we will go there, and from C, if we see this, so this is the, and this we refer as a final state. So, this is sigma delta q 0 f. So, what is our delta over here? So, delta is nothing but, so q is a b c, and sigma is binary string, binary symbol 0 1, and our q 0 is the A, which is the starting state, and f is C, the final state, and delta is the rule. So, we can have a delta this. So, we have A, B, C 0 1. So, from A we can go to 0, we see B, and from B if we see 0 we go C, otherwise we go back A. So, this is the this is the DFA, and that is the rule, transition rule, that is the transition function, which is a function from q cross sigma to q. So, we are at some state, we see the input, depending on that rule we will go to the another state. Okay, now we will see how we can read a string by this DFA. So, suppose we have a string say 1 0 1 0 0 1, this we want to take the input and we execute this on this. So, we start with, so this is our current state and this is our say symbol we are reading, and this is our new state. Okay. So, we start with the A, that is the q 0 starting state. Now, we are reading the symbol 1. So, now if you at A we read 1, we will remain at A, this is the new state. Okay. Now, again, so we are at A, we are seeing 0, then so if you see 0 we will go to B. So, we are at B, so this is done, now we are seeing 1. So, in B if you see 1 we will come back to A. Now, we are at A again, we will see 0, if we see 0 we will be again at B. Now, we are at B, now if we see 0 again we will go to C. Now, C is a final state, but our string is not yet end. We cannot say that okay, in the middle we are reaching to the final state. So, we will not execute the remaining part of the string, no, that is not allowed. We have to explore whole string, not the truncated string. Okay. So, we are at C now. So, yeah, we are at, sorry, we read 0, we reach to the C. Now, we are at C, now we read 1, so we reach to C again, that is by that rule. Okay. So, basically we put this in a tape, we can say this 1 0 1 0 0 1, and we read this tape. So, this sequentially, and depending on the rule delta, our state will be changing, and at the end of this if we reach to a final state, this is happen to be a final state. So, that is why this string is accepted by this DFA. So, this W is accepted by A, because at the end of the string it is reaching to a final state. Okay. Now, we can take another string, say yeah, if you take W to be say 1 1 1 0 1. Okay. So, we start with here, we see a 1, then we remain here, we see another 1. So, this is a new state, we remain here, we see another one, this is a new state, we remain here, we see a 0, once we see a 0 we will go here, then we see a 1, if we see a 1 we will come back to here. So, we are reaching to A after execution of this. So, this is we can define at delta hat. So, delta hat, because delta is defined on a alphabet input, and delta hat we can extend it, we will define that, we can extend it over a string. So, delta hat of this 1 1 1 0 is nothing but A. So, the meaning of this, after execution of this whole string where we are at, we starting with we are starting with q 0, that is the starting state, we keep on reading this string, we read this string. So, at the end of the string where we are. So, this is our A is the this state. So, this is same A, this is the DFA. Okay. So, now A is not a final state. So, this string is not rejected, it is not a accepted string, rejected by our DFA. Okay. Now, if you take say 0 0 0 1, this is our W. Now, what is delta hat of, we start with Q 0 0 0 1, we have to see. We are telling delta hat because delta is defined on the single input alphabet, and delta hat is we are extended it to over a string. So, we read the string, after that it is giving us which state. Okay, we start with Q 0, that is our A. So, we read 0, it will go to B, we read 0 again, it will go to C, then we read 0, remain C, we read 1, remain C. So, this is our C, which is a accepted state. So, this is accepted. This string is accepted by this DFA. Okay. So, this is not accepted. So, what was the earlier string? Earlier string was we can have a, we want to write this set of all possible string which is accepted by this. So, whether we can write it or not. So, 1 0 1 0 0 1, this was accepted, then this is accepted, this is not accepted. Any other string? So, can we have a general formula for accepting this DFA? Can you write this? So, is it accepting the accepts all strings which has 2 consecutive 0, because to accept we have to reach to C. So, how we can reach to C? If we can see 2 zeros, 2 consecutive 0, because we are at A. To reach to C we need to have 2 consecutive 0, that is all. So, it will accept all strings of zeros and ones with 2 consecutive 0, with 2 consecutive zeros. Somewhere, we do not care where, somewhere. Like this one, we have many ones, this is not accepted, but if we have another 0 over here, this could be accepted. So, this is the so it is accepting all the string which is having 2 consecutive 0 somewhere. Okay. So, can you write this in a like general way? So, can we just write this as this? So, this is again a language. So, we can just write this say x 0 0 y kind of thing. So, x is x or y coming from sigma star, any length. Yeah, we need to have 2 consecutive 0 in the middle. So, instead of x we can have, yeah, so we can just, x is usually referred as input. So, W1 W2, W1 W2. It could be if we have 2 just, so this is if W1 is epsilon, W2 is epsilon, this is 0 0, 0 0 is accepted, because we start from A, go to B, go to C. Now, if this is say does not matter, if we reach to 0 0, if you take 0 0, then any string it will keep on hop there, because in the C we are in the same state for any input, if it is 0 also C, 1 also C. Now, if it is 1 0 1 or 1 1, so this is the way we can write this. So, this is the so any string belongs to W, any string belongs to this is a accepted is an accepted string. Any string from this is an accepted string. Okay. So, we will always try to write this in terms of this, I mean that maybe it is not always possible to write in terms of this, in terms of a unified way, set way. Okay. So, now we will formally define how we can extend this DFA, I mean transition, DFA's transition rule over a string. We have seen the transition rule is defined on a input alphabet, but just now we have seen we can take the input as a string instead of a alphabet in a transition rule. Another input is a state. So, that we will define. We are going to extend this delta to delta hat. Okay. So, this is basically extended this transition function. Extended the transition function over to string. Okay. This is the formally we have already seen, because in the last example we have a DFA Q0 F. Now, this is a rule which is taking to the, now this delta we are going to extend this over a string. So, this will take a string W and it will go to a state. Okay. So, this delta is only take one alphabet, but this is taking string of alphabet. So, this is the formally we are going, we have seen the one through one example. Now, the formally we are going to define this. So, this is said, then if we want to write this in this form, delta hat is a function from Q cross. So, this is one input. So, this is sigma star. Okay. Because it is accepting it is taking a string as another input, then it is reaching to another input after end of the string. So, let us define this. How we define this delta hat on this? Okay. So, this is the definition of delta hat. Okay. So, first of all, this is taking input as sigma star. So, sigma star belongs to null set also. So, that is defined first. This is the base case. If we had q, we take sigma, the epsilon will be at remain q. This is how we define. This is the convention. We are, because in this DFA we are not having a epsilon move, but epsilon move will be there in NFA or epsilon NFA, but here we do not have any epsilon move. So, suppose we are at state q and we see epsilon, that means we do not see any input, then we will be at remain this state. So, that is the idea. So, this means no input, we are not reading the tape like this. This is the base case, we can say. Okay. And then the inductive step we have. So, suppose we take W from this and suppose W is equal to some x into x A and x is coming from sigma star and A is sigma, A is the input. Say for example, if W is say 0 1 1 0 1. So, this is x, this is A. So, this we write x A kind of thing. Okay. The last symbol we are just keeping like this. So, now how we define delta star on this? So, delta star on so we suppose we are starting from a state q on W. So, this is defined as delta of delta star of q x then A. This is the, that means, so this is our x, this is our W, this is our x, and we have a last symbol which is A. Now, we have a rule for A. Now, this is the inductive step. Now, we start from q, I mean q0 we start, but we do not know whether we are starting from the starting state or this may be in the middle. I mean, so now we first read this x. So, this will keep on execute and some after some time it will reach to a state say p. Then on p we can apply this delta on A. So, it will be a some r. So, that is the rule, that is the way we are defined inductively. Okay. So, we are just defined this on. So, this is basically the sequence x, x is again a sequence. Now, if it is only A, then x is epsilon. So, this will be remain in q, we take a we will go to the another state. So, that is straight away the application of delta. But if it is not A, if it is some more symbol, then we first take this one, then we apply this. So, lastly we will move to the state R. So, this is the way we define this delta. Okay. So, we take one example, say W is say 1101. Now, we take this as a x, this as a. Okay. Now, delta hat of say we are at q, we are taking 1101 as this. So, this will be defined as delta of, we first read x. So, after reading x we will be at some state and that will be by this rule, and then we will see a 1. So, where we are going. So, this is the way we will see it. So, we will just intuitively we start with the some state q and we keep on. So, we will go to p this. So, this is the delta hat of q comma x, we will reach to p. Now, from here we have direct delta. So, delta of p comma a. So, this is suppose r. So, this together is our delta hat of q comma w. This is the way we are defining that. This is the inductive definition of this. Okay. So, we will take an example, then it will be more clear. We will take an example. Okay, suppose we have this q0, q1, q2, q3 little bigger and q4. Okay. And this is our starting state, and say if we say 0 over here we will go there, and if we say 1 over here we will come here, and from here if we see 1 over here, so this is our delta, and from here if we see 0 over here we will go here, sorry 0, and from here, so this is our final state. So, if you see 0 or 1 anything we will go to q3, and from q3 if we see 0 or 1 anything we will go to q1. So, this is our, and from here if we see 0 or 1, we will hop there. So, this is one example of a DFA, deterministic finite automata. So, what is our Q? Q consists of Q 0, Q 1, Q 2, Q 3 and Q 4. There are 5 states. Okay. And we have this is our starting state. And what is our F? F is our Q 2. Okay. Now, this is our rule delta. So, delta is the rule delta so Q 0, Q 1, Q 2, Q 3, Q 4. There are 4 states and we have 0 and 1. So, if we see from Q 0, if we see a 0, then we will go to Q 1, and if we see a 1, we will go to Q 4. And from Q 1, if we see a 0, we will go to Q 4, and if we see a 1, we will go to Q 2. And from Q 2, if you see 0 or 1, both are, we are going to Q 3. And from Q 3, if you see 0 or 1, both are Q 2. And from Q 4, if you see 0 or 1, both are. So, this is our transition rule, the delta. This is not delta hat, this is the delta. Now, we want to we want to read a string like this 0 1 1 1 0 1. Okay. So, we want to see whether this is accepted by this DFA or not. To accept it, so we have to start with this Q 0, and this should be the accepting state. This is a string. So, that is why we put a hat. If it is just input, we will use the delta. So, this should be Q 2. If this is Q 2, then this W is accepted. So, we will see that with that. Okay. So, we are at Q 0. So, we read this 0, we will go to Q 2. So, we are at Q 0, we will see a 0, we will go to Q 2. So, this is the starting state, and from Q 2 we read a 1, then we go to this is Q 1, and we read a 1, we go to Q 2. Q 2 is a final state, but we have not yet completed the string, we have to complete it. Then we see a 1, if we see a 1, we go to Q 3, this is final state. We go to Q 3, we see a 1, again we see a 1, if we see a 1, we come back to Q 2, we see a 0, if we see a 0, again we go to, so we are seeing 1, again we see a 0, we will go to Q 3, and we see a 1, again we go to Q 2. So, delta hat of Q 0 and this W is giving us Q 2, which is accepted state, which is belongs to F. So, that means W is accepted. W is accepted. Okay. So, this is the one example. So, so we can try to have a general rule for this, how this is accepting. So, then in the next class we will discuss more on this, and we will formally define the what is a regular language. Regular language is it is a language which is accepted by a finite automata. So, we will talk about this in the next class. Thank you.